It's my pleasure to introduce Peter Wang from Continuum Analytics, and thanking Continuum for helping us organize and host this wonderful event here at Facebook. So Peter holds a BA in physics from Cornell University and has been developing applications professionally using Python since 2001. Before co-founding Continuum Analytics in 2011, Peter spent 7 years at Enthought designing and developing applications for a variety of companies, including investment banks, high-frequency trading firms, oil companies, and others. In 2007, Peter was named Director of Technical Architecture and served as a client liaison on high-profile projects. And he's also developed Choco, an open-source Python-based toolkit for interactive data visualization. So let's please welcome Peter and what I hope will be a very, very interesting talk.
All right, thank you, everyone. So first, I'd like to give a great big shout out and a very warm thank you to Facebook for hosting us. This has been a fantastic venue, and let's just give them a big, big, big round of applause. So I hope everyone has had a good time here, has learned at least one thing, maybe two or three. And what I'm going to talk about today is, well, it's kind of a wandering talk, but it talks about a number of different things. But overall, the theme is about PyData, the past and the present, and then the future, and where we're going to go. So I think maybe the first question would be to sort of ask, how do we get here? Like, why did Facebook open up their campus for us? How is that we got, hundreds of people here to talk about all sorts of great stuff? And if you look, these are some photos from 2 years ago when we did the first sort of Python data workshop. And at that time, Google stepped up. They gave us a couple of rooms in their headquarters and provided free food. It was fantastic. And then Julie Steele, is Julie here? Is she somewhere? Maybe she doesn't want to be identified. Oh, there she is. She's in the back. Julie really helped out tremendously by putting all that together and coordinating. Wes was also an organizer, and myself at Continuum. And we just got basically, I sort of saw this need to organize users and developers around the topic of Python for data analysis. So it's deeply connected to scientific Python. We've been having these SciPy meetings or conferences for a long time. But I definitely saw there was a different user community around this data analysis space. So basically what we did is we emailed a bunch of our friends, who are devs in the SciPy community. We got some other people registered. And we just had a really great time. And one of the things, we just come from exhibiting at the Strata conference, which is Santa Clara, and Julie also helped run that. And so Travis, my co-founder, got to see firsthand, that was his first contact, sort of first exposure to what the data analysis or what the big data and data science community looks like. And so, the year before I had gone to Strata, which was the first Strata, 2011, and I walked around and every single vendor was talking about Hadoop, but every single tutorial and practitioner was talking about Python and R. And so, so basically, Travis saw this now, 2012, and he gave at the PyData workshop, he gave the room full of our friends and fellow developers and users. He was giving this talk, asking questions like, what is the role of Python in the space? He put up controversial pictures like, snakes swallowing elephants drawn by princes, and all sorts of crazy talk like Python could be a peer DSL to C++ on top of the LLVM infrastructure. And so things like that. But one thing that was really cool was that Guido, who was working at Google at the time, came by and chatted with us. And so he took a bunch of questions in a panel format. It was really very friendly of him. And so here you see sort of, I don't think it was quite this conversation, but I'm just sort of, you can imagine, right? Travis saying, look, please help us convince the Python core developers. This, again, 2012. Please help us convince the core dev to work with us on solving the packaging problem. And Guido, he takes a lot of requests from a lot of people as the creator of the Python language. And he had a really great response. He said, fix it yourself. And and so it's sort of like, okay, challenge accepted, right? But actually, some of you might, sometimes I talk about the packaging problem. Some people here, I think, know what that means. But a lot of times, especially like on Hacker News or the Python subreddit, you sort of get this like, what packaging problem, right? So people are like, well, I just use pip and virtualenv, and it works great. Or I have Homebrew on my Mac, RPM and apt-get. I mean, any Gentoo users? right? I just untar some things, or I double click an MSI file. Maybe I just make some stuff, or I like export a Python path to a git checkout. And if you do these things, or for those sorts of users, I feel sort of like it feels sort of like this, sort of like it sounds great. It sounds great, but actually maybe more appropriate would be something like this, because the instant you need to run your code on any machine that's not your machine, or on your machine 3 months from now, you're going to run into a problem. So more seriously, I guess, this is what I sort of mean by the packaging problem. This is kind of a warning for any of the old timers in the room. This slide may actually trigger some like PTSD, but basically, packages, they didn't actually exist in the Python language design like in the beginning, and they were added sort of later on. And Guido sort of has never been that particularly interested in them, and I think it sort of shows. But I've been watching Python since the beginning of this particular evolution. Like '99 is when I really started using Python, and so I've sort of seen this unfolding. So I've seen this sort of unfolding, sort of like this train wreck in slow motion. Except it's multiple train wrecks where one train comes in, grabs the previous train, backs up, and plows in again. So, and that's sort of what this picture shows. Sort of like, well, we're going to use setup tools, but no, actually it's going to be distribute, or distutils, we're going to fix that, or, well, everyone's using pip now. And so that picture right there is actually around 2013, I think, is sort of like, there's some pun here around train wrecks and wheels, but I couldn't put it together. But anyway, you guys work that out. But the question is, how many people here, I'm just curious, how many people here understand that picture? Okay, how many people here want to understand that picture? Seriously? All right, I was going to say, because I was expecting no hands, and then I was going to say, here's the quip, all the people who would otherwise raise their hands are off at the bar crying into a beer. So you have that. So in a sense, when Guido came in and said, you guys fix it, we were like, okay, that was actually very liberating. Okay, because we took him on his word, and we created Anaconda and Conda, and we're like, now we're good, right? And so whatever happens, Python, we're still, we keep in touch and everything, and I think they're aware of what we're doing, but it's still one of these situations where the scientists and the data analysts and PyData in the PyData and SciPy communities understand the needs much, much better, I think, than core dev really did. So anyway, kind of backing up a little bit then, overall, that was kind of the initial kickoff. That was literally at that workshop is where Travis and I sort of looked at each other and were like, we should create a distribution and create some tools to make this better. So that's the beginning of Anaconda and Conda was right there. So then, in the subsequent 2 years, we've had a number of very, very successful conferences. Leah, can you stand up, raise your hand? She's not going to stand up. Leah has been absolutely instrumental in making all this happen. The dirty little secret is when you email admin at PyData, it goes like to her phone. So it's but this is also a community coming together, a community of users, a community of developers, people stepping up to organize, people stepping up to get their companies to foot the bill for sponsorship or to provide a venue. JP Morgan in October of last year gave us this gorgeous space in their big skyscraper in the financial district. So. We're doing it again this year, actually. If you look, in July, we have PyData Berlin. In October, we'll be back in New York. And we'll have sort of two events. One, we're going to have a PyData Day kind of as part of the Strata conference. If you're going to Strata, just look out for that, something you can do. We're still finalizing the schedule, but that's something that's in the works. And the other thing is that we're going to do another New York conference in October, but we're looking for a home. So if you have friends who own companies and skyscrapers in New York, be sure to get in touch with Leah. All right, so... but that's how we've been kind of going. So this is the first 2 years, which is actually a short amount of time to doing all these conferences, growing this community from like a room full of people to the kind of very, very large population that we have now. But if you back up a little bit more and you say, well, that's just the conference itself, right? But really, PyData builds on top of the tools from the scientific Python ecosystem. So in the last 10 years, these are the sorts of tools that have come around, right? So IPython Notebook was really officially released in 2011, but there had been work around this area since like 2005. And then Pandas, as Wes said, I think I have the timing right on that, but I think he started in 2008, but certainly the first public release was sort of towards the end of 2009. Scikit-learn 2007. NumPy itself actually is relatively new, 2006, which is still less than 10 years ago. But of course, NumPy and all these things build on top of SciPy, right, which started in '99. IPython was '01 and Matplotlib '02. There's actually a lot of deep history in the tools that we're using now. It's really interesting to go and teach Python to people, and all of this is so new to them. And it's like, this is actually really mature technology. Millions of people banging on this stuff. It's in production everywhere. And actually, one thing I should mention: if you are using Matplotlib, if it's actually useful for you in your work, you should go to numfocus.org/John Hunter and contribute to the John Hunter Memorial Fund. John started in 2002 as a labor of love. He's shepherded the community throughout his time on the project, and so it's definitely something you should do if you use Matplotlib. Especially if you give Kickstarter campaigns for random stuff, you should kick in some money for the fund. So. Anyway, so backing up even more, 20 years, right? The last 20 years, what's happened? You can actually see that the origin of the use of Python for scientific computing and numerical computing is very, very, very long. So NumArray was started in 2001, and it was sort of a light fork, or sort of I guess it's basically kind of a fork of numeric, which started in 1995. And NumArray and numeric were two very different, they had different sort of things they were optimizing for, and they were not really compatible. And so people had things like the numerics library. How many people here actually remember numerics? Have you used numerics? Yeah, a few people. Right, that was a terrible time. I would actually say if NumArray and numeric, if that rift did not get merged, that would have fundamentally forked the ecosystem. We would not be where we are today. And so what Travis did in 2006 with NumPy, he spent the year building NumPy. That basically pulled these two halves of the world back together, and then everything else, all the innovation since then has I would say to some extent been possible because of that unified, cohesive library. But if we go further back then, let's go all the way back, right? When did Guido, so he looks so happy in that. That's his Wikipedia picture. He looks so happy in that picture. It's taken a while ago. So Python, he actually started Python as a weekend project in '89, released it publicly in '91 out of CWI, and then and version 1 was actually, it wasn't until several years later in 1994. And that's 20 years ago, right? Actually, if you look, so when he talks about it, he'll talk about the history of Python. He'll say that actually it was inspired by ABC and Settle, which are these languages that were being worked on at the time, or ABC was at least at CWI. But he wanted to make something like that appealed to Unix and C hackers. Now, if you want to see what that looks like, if you want to see what version 1 looks like, you can actually conda install it. So we made that as an April Fool's not joke. Just a month ago, and so you can do things. You can actually look at the blog post. Just as a warning, there's no lists, there's no dictionaries, there's no Boolean constants, and there's no read line, so you can't press up and down. All right, so good times. But if you look again, what is this ABC thing? ABC, if you look at the Wikipedia article again, it's interactive, structured, high level, intended to be used instead of BASIC. It's not meant to be a systems programming language, but it's intended for teaching or prototyping. Right, so this is actually very interesting because this means that Python has its roots in a teaching language. It was inspired by a teaching language, and it's actually one of the only modern languages, I think, modern application development languages to be able to make that claim. Like Pascal, Delphi, Pascal was sort of a teaching language. Delphi is used in some places. Scheme, I don't know how many people use Scheme in production though. VBA, Smalltalk, that's true. But again, it's a fairly small adoption in terms of across a smattering of languages now. And VBA is heavily used, but it's so far derived from BASIC that it's kind of hard to make that connection. But I would say that this is actually, again, a really important point because if you look at before the Zen of Python, before import this, before one obvious way to do it, before all of these various things, the creator of the language was basically doing this by design. He wanted to make it accessible by design. And actually, I would say throughout the evolution of the language, that design guidance has remained fundamental to a lot of the decisions, a lot of the no's, and some of the yeses, actually, behind what's grown Python as a language. So when we see efforts like software carpentry, we have universities switching wholesale their CS curriculum to Python. We have boot camps like the Women Technology boot camp that happened yesterday. All of these things where people are teaching people how to program with Python, that's not sort of an accident. It actually was somewhat by design. And there's this great saying I like that it says, any idiot can write a program that even a computer understands. Okay, so the key thing right? And the key thing about Python is that it's a language that affords writing programs that other humans understand. That's actually a really important thing. Who knew? Not all humans are mechanical Turks either. So for the non-mechanical Turk humans, maybe. And so many of you have probably heard Mark Andreessen's quote that software is eating the world. And I really fundamentally believe this, right? Because computers are, obviously they're everywhere. They affect every aspect of life, every corner of the planet. Other planets, if you guys saw Rob's talk yesterday, NASA JPL, relying on software to drive cars, on Mars and to control satellites out beyond the edge of the solar system. Actually, I would say that it's probably the most badass cloud computing. It's, the Oort cloud computing. But one sort of there's a different twist on this too, which is software eating the world sounds really great if you're a programmer. But the other thing to be respectful of is that when software meets the world also changes software, right? The world is starting to make software. And when the dust settles, certainly the world is completely transformed. But the practice of software itself will also be transformed. And so how many people here, out of curiosity, how many people here do not have a degree in computer science, but do write software as part of their day-to-day job? And that's the world eating software, right? That's the other way around. So the users are really hacking the asylum in this case. We're not just waiting for the gods of CS to deliver us stuff. We are just making stuff ourselves. There's actually, this wasn't always possible, right? Back in the day, computers and languages used to be really hard. This is a 1979 book, really, really great bedtime reading, actually. But it's about the Burroughs 5000 and the people who were there. And in this particular excerpt, it talks about this guy, the author, who was meeting this college kid named Don Knuth, who claimed that he was going to come and bang out an algol compiler in the summer. And none of the people believed him. They just didn't believe he could do this. For $5,000, he was going to do this. He needed magnetic tape, not punch cards, but he would just build this algol compiler. And so they started asking around about this kid. And apparently the scuttlebutt was that the kid had already written the compiler. So it was already done. And so anyway. But what's funny about this is that it took a Knuth to write a compiler, and no one believed he could do it. Whereas if you saw the keynote talk yesterday, you can just build DSLs on top of Python in Python, and you can use dis and AST and bytecode, all these various modules to transform the language and build your own, make it your own. So compilers aren't that hard anymore. And I think building compilers and DSLs is actually going to be something that Pythonistas are going to have to get more comfortable thinking about in general. One of the main points of my PyData New York keynote in October was that really the hardware and software stacks of the last 20 years, they're no longer serving the needs of business computing. We've been told that traditionally we have each of these different layers of abstraction. There's languages and there's different ideas and different sort of concepts to think about at each level. And then the experts at the hardware level provide us these low-level languages, and then the experts there will write language runtimes for us. And then finally, we as the pros at the top will get to write scripts that make these things do useful stuff. But that tower of abstractions is really, really broken. And I guess in some sense, you can think of I think of the cloud computing and the big data disruptions both fundamentally arising from the brokenness of that model, but on different ends of it. So in my view, and our technical view at Continuum, is that we'll get better performance and better productivity by staying at the higher level and then compiling downwards. And it's not just us. If you look at other languages, whether it's a JavaScript and shadow classes and V8 and JIT compilation, whether it's the JVM, lots of other places are doing this. So this is, again, not a bunch of theoretical hand-waving, right? So this is two instances here, AdRoll and the DeliRoll architecture. They're using Numba, the compiler that we have in Continuum. They're using that in the middle to take Python code and then put it right in the middle of their high-performance analytics stack. Cloudera, just this week, came out with a blog post talking about using Numba to compile user-defined functions for Impala, written in pure Python, compiling this down to machine code and running them, and they run as fast as the C or the Java equivalents. So this is real, right? And so back in 2001, this was a very kind of embarrassing for me to actually reveal this, but I posted on Complaying Python, right, about what are some of the best development practices, and there's a whole thread that went off about static typing, as you would imagine. But the thing is that Paul Rubin had this really great quote that he says, sometimes Python can be used as a workhorse, sometimes it's a racehorse, but neither fits in a glue factory. So this idea that Python is just a glue language. And then Tim Peters came back and really liked it, even winked at it. So the interesting thing now, though, is that actually I think we're in this interesting space where being a polyglot language, being something that plays with other languages and other runtimes, that's actually an integral component of performance. So in this vision of Python as Glue 2.0, it turns out that the glue horse works, pulls harder and runs faster. But I think that metaphor doesn't quite work. So anyway, but the idea here is that this is sort of the technical rationale for our DARPA work, the X-data work that we're working on. Blaze is really sort of that bulk data descriptor, and then Numba is a compiler engine to allow Python to talk to other languages and other runtimes. And I think this kind of vision, it's going to take a while to get there. We're working on it. We're making really good progress, but certainly, it's a work in progress. So let's switch gears a little bit and talk about data science, right? Let's talk about the hard problems in data science that people are using these things for. There's sort of there's too much, I think, discussion out there already about the hard problems, right? Every middle manager will say like the 3 Vs, and they'll kind of like mug at you. So we already know all this stuff. There's lots of data, there's lots of computers, and just a whole bunch of different tools, new tools every week. I'm not really going to go into detail on a lot of this stuff. I will just say that I think most people, to first order, most people say big data when their Excel blows up, and that's kind of when they start thinking like looking out at the world of big data. But for people in this room, right? I mean, we know there's something real here. It's sort of this very new and different thing, this idea of a data-driven business. In Strata 2012, I think it was, I heard a plenary talk where it was really fantastic, actually, this idea that data will become substrate. I think that probably resonates with a lot of people in this room. And I really believe that. I believe the world is very much on the edge of this, on the cusp of a data revolution, if you will. Especially, here we're at Facebook, we're, looking around all the practitioners here from all these different companies, big and small. It's very easy to believe we're right in the middle of it. But I think it's actually just beginning. So if you think back to like 96 and what it meant to be an internet true believer then, you could already see kind of the shoe starting to drop, right? Like the web was a few years old already. 93 is actually when the AOL put all of their users on the internet. The term, of course, for that is Eternal September, right? When the internet started to suck. 94 is when Steven Sinofsky, a Cornell alumnus, sent an email off to Bill Gates and said, the internet is alive and well at Cornell. We should pay attention to this thing. And Bill Gates was like, oh, okay, consumer internet. And that's when Microsoft really started to pay attention to that. So 95, Java was released as a network operating system, for the web and just for the network. So by 96, it should have been pretty obvious to people that there was no going back. Every business pretty much recognized this. And again, it's not an option. It's not like, oh, it would be nice to be. It's not an optional thing. If you don't, then you will be destroyed. And I think we've seen that play out in the last, almost 20 years. And so I think we're actually in a similar spot in 2014 relative to the concept of a data-driven business and what that means. So, in the sense of like, I don't care what your business does, whether you're drilling for oil, whether you're grooming pets, whether you're, shipping postcards around. Fundamentally, if you're not data-driven, then in a few years' time, it's just a matter of time. Some other competitor that is data-driven will come and destroy you and take your lunch. So, I guess what I was saying is like 2011 is equal to 1993. Maybe in JavaScript that's true. I don't know. They don't have integers. They use floating point. You never know about precision problems. But in any case, I think the idea for those who are there, those who know the history of that, I think you sort of see these things happening, right? So there is a real opportunity here. And instead of talking about the hard problems data science that sort of are in the way of those opportunities, I want to talk about the soft problems. And I would say actually probably the biggest or the hardest meta problem is really that there's the multiple disconnects between multiple things, many different groups of people. So I'm calling them soft problems because I think they're about communications fundamentally, not any particular chip getting faster. So if you think about the traditional model of business computing, you have a bunch of double E's making computers for you. You have a bunch of CS graduates writing software and applications around that. So you don't have to go and toggle switches on a computer. And then you've got big data, and you've got like math and stats grads that are delivering insights to you. They put in an Excel notebook and then or workbook, and then they give it to the actual management, business decision makers. And that's the happy world that everyone wants to live in. But we all know that's not actually the reality, right? The reality is that the traditional tools and those abstractions, as they break down, you end up with more and more of the underlying abstractions leaking through to the point where data scientists now, they have to understand the data and the actual analytical problems and the stats and the machine learning and all these other things. But if they want to understand machine learning, they've also got to understand something about GPU programming, right? Because now, of course, they know about hardware, I guess. And then they're also writing distributed runtimes. And so really, In the middle of all that stuff, they have to then produce insights to the front-end business decision makers. At the same point, the business people really want to get very agile responses back from this infrastructure. So you have this back and forth happening, and you have the data scientists sitting kind of very much in the nexus of this interaction. And it's not really that pipeline anymore. And really, I mean, it's painful to be in that spot, but it's also really amazing, right? Because if you're at the nexus of all of this stuff, it means that you probably have a little bit of job security. And more importantly, it's actually probably the right way to run a data-driven business. So that gap and all of that multiplexing, obviously people here in this room would agree, I think, that people are doing this with Python very successfully, doing more and more of it with Python, in fact. Because you really need a tool that gives you fluency and gives you confidence over your data problems. So I'm actually very grateful. This is the data science salary survey that O'Reilly put together and published, I think at the very beginning of this year. But what you see there is that Python and R are neck and neck. They're above Excel in popularity, above Hadoop, above any of these other things. They're just below, not just below, but they're second only to SQL, which is really, I think, eye-opening for a lot of people, but also reaffirming and validating for us in the Python community, right? That we've known, our bet from 2 years ago, we had the first Python data workshop, was that Python is a great tool for data analysis, even just using the scientific tools and improving them a little bit, and I think this really validates that. So I'm actually kind of curious, how many people here have a background in physics? That's a lot of people. That's awesome. So I guess all of you will know very viscerally, right, that physics is not just math. You need to have sort of physical intuition. You need to have knowledge of the domain, but you also need to have this kind of scientist mind to formulate good questions and hypotheses. And so in the same way that I think math is a language that physicists use to get kind of fluency and cognitive mastery over their problems, I think Python can be a tool for data scientists to achieve mastery kind of over their data and computing problems. Because data science is more than just stats, right? It's about modeling data using computers, doing really robust modeling using lots of computers over a lot of messy, noisy data. It's actually kind of interesting if you think about it that a lot of the advances in mathematics, some of the major ones, came from physicists. Like they had to invent new things to solve problems that the previous tools couldn't deal with, so like calculus, for instance. And so I would say that software is actually a cognitive tool as well, not merely an application that you point and click and export to Excel. So the point and clicking kind of works for some things, but if you need a tool, if you need to actually have cognitive mastery over a domain where you're generating hypotheses, where you're thinking about new questions, you have to basically be able to cook, not just select from a menu. And so one of the terms that I heard, or one of the phrases I heard pretty recently, I thought was really great, was that Python might not be the best language for everything, but it's almost certainly the second best language for anything. And I tried to find the source of it, and I Googled around, and it turns out that people said the same thing of C and C++, and of JavaScript and Bash and Perl. So I'm just going to stick with Python. But I'm going to argue for why it's true for Python. Maybe not exclusively true, but certainly true for Python. Wait, I guess it has to be exclusively true. Okay, well, the idea here is that I think it blurs the line between user and maker, right? So if you look again, I didn't put the names of the people because there's just too many, right? The community actually is very large for a lot of those projects. But in the very first slides, I showed all of those tools over the last 20 years that people have built. In the Python scientific and data communities, the vast majority, I would say almost all of those tools, are built by people who are users. So we stand on the shoulders of the users who became makers, right? So something I hear a lot from people who use R and people who are promoters of R is that R has a great user community. There's any statistical algorithm you can find in there, but also there's just so many users. And what I want people to say for the Python community is that we have a very strong maker community in Python. Because unfortunately, if you go and try to use some of those things in the R community, it's hit or miss, right? Whereas in Python, a lot of open source projects, you're embarrassed if your docs are not good. People will shame you about lack of tests, and that's okay. That's good because it's makers, right? It's a community of makers and users. There's, again, another really great quote is this idea, of course, that science, right? Science advances because we stand on the shoulders of giants, which was a great, noble quote. And then the sad truth, of course, about programming is that we stand on each other's toes. And so I would like to think, again, about this idea of users becoming makers is that in Python, we stand on each other's shoulders, right? This is kind of this community that bootstraps itself. there's a really great quote, kind of back to this idea of writing programs for people. This really ties into that, right? The author of The Little Prince has this great quote that there's one veritable problem, and that is the problem of human relations. I've always loved that quote, and it is so true. It's just so true in every aspect. As I get older, as I do more things, interact with more people across a broad spectrum of areas, I just find that quote validated over and over again. Back in 2010, before all this data stuff, I was still at Enthon at the time. At the SciPy conference, I gave this, I think, the mother of all lightning talks, where I sort of hijacked lightning talk slot and went on for 15 minutes. By the end, everyone was laughing, so I think it was okay. But I've been thinking about this problem actually for a while. What I'm trying to press upon you here is that I've actually, even since then, I was thinking about, at the time, I was like, really reflecting on, this is great. We have a great user community. I was having a great time at SciPy, meeting all of my friends and all the other people in the community. And I was just kind of contemplating, why are we here? How do we get, same question I'm asking now, how do we get here? What does the future look like? Will it always be this way? And what happened at the time, I was motivated to give this lightning talk because I was reflecting on the enterprise adoption of Python. Right? Python meets the enterprise is going to be the title of my talk. And what I had slides like this one, I had slides like this, like actually not that enterprise, this enterprise. I also sort of poke fun at Java programmers. And then I really settled on this idea of like, what are the things that are true about Python? Why do people like it? Why are all these PhDs and everything from every aspect of science, why are they using it? It was really interesting. If you go to SciPy, I don't know how much happens now, but back then, every single person, they could be like, a 55-year-old researcher from some national lab. They show up, and before they give their talk, there's this long paean about how much they love Python, how great SciPy is, how much they want to thank the developers. Every single talk. And so I was like, why do people love Python so much? And so, again, prior to that conference, I spent a little bit of time working through an enterprise Python code base that was, for lack of a better term, unidiomatic. And I don't think the authors of that code base would have gone on stage and waxed poetic about how much they love Python, for instance. So I wanted to talk a bit about the Python language, about passion and creativity, all these things. And I settled on these different ideas, right? That Python gives you, it has there's this idea of mastery, that if you spend a little bit of time with it, you can get some stuff done. If you spend a lot of time, there's actually a lot of depth. You can get really, really interesting performance. So the way a violin is different than a kazoo, Python is different than Excel, right? So because you guys see like the A is to B is C is to D. So the idea, though, is that additionally, because it's readable, there's actually a network effect. Because the people who are really, really, really bright and motivated can get down and build cool things. They can be makers that then they can give to everyone else. They can disseminate to everyone else, and it's not a magical pile of pearl. It's actually something I can approach and learn from and read. I can read how these other libraries I use and love are written. I can go submit things to them, and then I can grow this community. So that network effect is amazing. So I also talked about community, actually. That was one of the things I was thinking a lot about at the time. And I sort of gave people this admonition of things to do, right? Things not to do. And really encourage people there to be very deliberate in how they introduce Python into their enterprise environments, to their friends and possibly frenemies. And so that's sort of, that really is my fundamental point. That brings me to this idea of, and the subject of community, that 4 years ago, right, I was focused on how do we grow the community, but that was just at SciPy. At PyCon this year, and actually for the last however many years, the same point is repeated. So how many people here went to PyCon this year? Or have been in the last couple of years, maybe? A couple, three? Okay, good. Yeah, a good number of people. And you'll probably have heard this statement that Python, you come for the language and you stay for the community, right? And it's so warm and fuzzy, it almost makes you hate it because it's so warm and fuzzy. But it's true. It's just wonderful. There's nothing wrong with that. It's just wonderful. And so what I want to see is that I want to see us grow a very strong data science community as well. And what I see looking around and just talking to people is that there are a lot of people coming into Python, picking it up, and using it for these data science tasks. A lot of new people coming in the door, and what they see when they go into PyCon, for instance, is see a lot of very, very welcoming people, a lot of just kind of like people beating the drum about community. I want to make sure we have we establish that same kind of ethos here in the Python and data science communities. One thing that is, so for all of the goodness of PyCon, the Python core development community, actually, they don't really know a lot, I think, about what we do in the SciPy and the Python data world. It's sort of a mystery to them. And there's many core devs who've never imported NumPy or even looked at pandas or made a plot with Matplotlib. And so it's not their fault. I mean, they're working on a core language. That's what they do. They're CS people. But in the scientific Python world, we sort of have to mind our own. We have to grow our own community, right? One of the saddest things that I hear actually is when someone in a company or maybe someone posts on somewhere on some social media or some LinkedIn group, they're like, well, we're interested in using Python, but we're probably going to just use Java because it's so hard to hire Python programmers. There's just not enough Python programmers out there. And what they're really saying is it's hard to hire good Python programmers. But you find lots of people with Java on their resumes and just bring them in. But the challenge, that's a real challenge for us, right? I mean, imagine if you want to go and build a Python stack at a company and you get pushback from people saying we just can't hire Python programmers, not enough of them. So if you want to keep using Python, if you want to see Python grow in its adoption in various places, we need to make more Python programmers. And the way we do that is by having a welcoming community, having a community that really, again, bootstraps itself, that reaches out and includes everyone. So I would sort of, I guess the admonition here and the charge that I would give to everyone is to participate, right? Actually step in and participate, whether it's on social media, whether it's through GitHub, whether it's through private email or mailing lists. Wherever you see Python being discussed, wherever you see data science being discussed, step up and represent. Say, I did this problem with Python. And all the other SAS programmers will be like, oh, you can do that with Python. There's so many environments right now where people simply don't know what's possible. I've stopped being plugged into some of them because they're so frustrating and they take so much time. But you definitely know. I mean, all of you know, as the world of data analytics and business data is being transformed, there are a ton of people whose eyes are opening and looking around. We want them to see Python and see how great it is in the Python world. I'd also encourage those of you who are in areas that you find like-minded people to start PyData meetups. Just even if you meet up for drinks or for a quick lunch or something, it's great to make that personal connection with people. Again, back to the Little Prince and to Antoine de Saint-Exupéry, the human relations is actually such a fundamental part of how of everything, but certainly in computing, it's an under-discussed and underappreciated aspect of it. But the really successful technologies, I think, that we're seeing now, at least in the open source side, they have very strong communities behind them. And also, of course, I would encourage everyone to keep doing what you're doing. Come to PyData conferences, submit talk proposals. And I would also encourage you to work hard, everyone, whether you're underrepresented minority or not, to work hard to increase our representation there. So reach out to friends and to people, coworkers and collaborators that that you think are doing interesting work. Really lean on them to submit talk proposals. Really, try to bring them along. And if there's if there's financial hardship, or if there's need for any kind of sponsorship, we do have diversity sponsorships, things like that are available to us, and through the PSF and through our other sponsors. One of the things that actually is very interesting, again, for those who went to PyCon, is if you've been going for a number of years, you can see the hard work done by Steve Holden and Jesse Noller, all the PyLadies, everyone there who've been involved in increasing diversity of attendees to PyCon and speakers to PyCon. What they've shown was interesting. This year they had a massive, relatively massive compared to technology in general, but they had a really, really high turnout of not only of attendees, but also of female speakers. And I think in the years before, like 8 or 9 years ago, you could go and you could step up and you could say, well, I just don't think there are enough women here. What can we do? Someone could say, well, there's just not enough women in technology, period. I think we're doing fine. And what PyCon has shown that if you have a sustained effort by the community over a long period of time, you can absolutely change that. And actually, there are a large number of underrepresented people who are not showing up because of a number of different factors. And so I would encourage everyone in the PyData community to think about how we can improve. And it's the hardest thing about efforts like diversity outreach and things like that is not like one big thing where Guido says, now we're going to go to Python, like diversity. That doesn't work, right? It's millions and millions of little things, little actions sustained over a long period of time. And that's what's so hard about it. I think it takes commitment overall from the community, from everyone. So I just really want to emphasize that point. We had a Women Technology event. I don't know how many people are aware, but we had, I think, something like 60. Where is Cindy? I think she was something. It was like 60 high school girls showing up, learning to programming Python. They sort of sucked all of the female attendees away parts of the time to go and help. But it was this really amazing event. And in October, we did the same thing at JP Morgan. They brought in a bunch of female high school and actually even some middle school students, I think. And there was an amazing, sort of STEM, women in STEM sort of event that was getting people to program for the first time. Getting all these girls actually hands-on keyboard writing their first program. And it was so empowering for them and just so rewarding for the people who were involved. So things like that, I think, are ways that we can absolutely differentiate ourselves as a community, not just as a technology, but as a community. So just to recap, I sort of talked about how we got here. And overall, I think, if you had to distill it down to one slide, it would just be, hard work. A lot of, so that the whole thing about science advancing one funeral at a time, sort of a morbid but true statement. I think scientific Python and Python data advances one postdoc or tenure at a time. Sort of people who, burn through a postdoc or burn through a tenure to build some library that everyone loves. So a lot of hard work, but it's hard work by a community of people. And it's people who actually cared about the tools, who cared about doing good work for their collaborators, for people thousands of miles away they've never met before, except maybe over email. And not only do they care about not only do they care about the code, right? They care about the people. So where do we go from here? I think it's pretty much the same thing, right? More hard work, more community, more caring, more code, more people, and just more in general. And so the underlying point here, the last thing, is this idea that we can talk about Python being a glue language, about it being glue 2.0. We can talk about it being a polyglot environment. The IPython folks are doing great work with having IPython Notebook be about all these languages coming in, whether it's R or Julia or what have you. In my own project on Bokeh, we have a small interface now in Scala. We're interested in having Clojure and R and all sorts of other sort of interfaces built to it. We're interested in Python being very much a polyglot ecosystem, but that's just code, right? That's just Python as glue code. What's really, really important, I think what's equally, if not more important actually, is that we want Python and PyData to be communities. So when we do SciPy, we invite the developers of Julia to come and give keynote talks, right? When we do PyData, we welcome people to come from the R and other communities and share their expertise and their perspectives with us. So that actually, this is a record. For the first time ever, I finish a talk with time left, which means I must have talked really fast. But that really concludes the slides. And I don't know if there's any questions. I guess we can just open up for questions and comments. Nothing.
This is kind of more of a question going back to the beginning and talking about Numba. Do you ever see a future where you do something like Numba to LLVM and then maybe through and script into JavaScript? I mean, a lot of people have tried to do this, right? Like, how can we write Python and turn it into JavaScript and run it in the browser? From your experience, like a Continuum, do you see a future for something like that, for like using LLVM as a glue between Python and JavaScript?
Yeah, actually, I have lots of opinions about JavaScript. So depending how deep you want to go down the rabbit hole. What I think is very interesting, my fundamental idea about JavaScript is that it is right now, let's see here. What's interesting to me, I think the most interesting thing about JavaScript development overall is the emergence of ASM.js. And what ASM.js really says is it's browser vendors and other people who don't use JavaScript saying, hey, we really like each other. And we have to go through this serialization interface called JavaScript. So you can imagine ASM.js. So those who know or don't know, perhaps, ASM.js is sort of a way of writing JavaScript such that you're hinting to optimizing JITting JavaScript runtimes so they know, oh, this is an int. This is how I declare an int. Not by saying int, like a proper language, but by saying this number and then bitwise and whatever. So you could actually easily do this with comments, right? I could have statically typed Python, asm.py, where I put a comment above every single line and I give you like this full type declaration for every single variable, right? So you can do things like that. And so ASM.js is, I think, the emergence of it shows that there is interest from both sides here that are not JavaScript programmers to build better bridges. And I think things like Dart and TypeScript, all of these things are basically saying the browser's a great runtime, but this language, could improve. So using LLVM, using Numba as a gateway to the Inscription ASM.js sort of front end, I think absolutely can be done. The big challenge The big challenge actually in languages is not so much the AST transformation and the expression graphs, but actually the types and the semantics on the underlying types. So I think if we can figure out nice or what are meaningful subsets, right? That would actually be very interesting, because then that means you can write browser. Then what you could do, by the way, Numba is written in Python itself, for the most part. We have a Python wrapper around LLVM. So there's no reason you couldn't use Inscription to compile LLVM itself and to compile Numba so that it all runs in the browser. And then you type Python in the browser, which then compiles in the browser to the browser, right? It's all fine. I mean, it's just a runtime. But the question is, will other languages get there faster to where we actually have nice, pleasant languages that we can sort of co-develop with Python? Because I don't mind writing a little HTML, right? I don't mind writing a little CSS. Writing like a bunch of JavaScript, which then I wrap in braces and evaluate real quick. Like that's just a terrible way to live. So that's the, like I said, I'm opinionated about this stuff. But I think the compilation into the browser is an area that, yes, you're right, people have been trying for a long time. And there's things like Python, right, which are just like subsets of Python that are maybe good enough to run in the browser. But again, the challenge is semantics of the underlying types. And how much are you willing to limit that in what you can compile? There's a question. I think Raymond had a question back there, right? So I don't know if you guys know, but ladies and gentlemen, Raymond Hettinger is one of the core Python developers. Has created wonderful, he's just been an integral part of the language for a long time. And so he has graced us with his presence here at PyData today. So I'm...
For a long time, people have wished for a matrix operator.
Yes.
Matrix multiplication.
Yes.
What's it going to do for us? Predict the future.
It will get more people using Python 3, I think. Actually, so matrix multiply was one of the things that came up. There are three things I remember coming up in that panel with Guido at the first PyData workshop. One of them was the packaging stuff. The second was matrix multiply operator. And the third was this idea of writing little DSLs. Like, we want to write little DSLs. We want to do like, everyone here is probably familiar with the idea of pass by reference and pass by value. What Lisps and functional languages let you do is pass by expression, right? I can write a little expression here and just pass the whole thing in. And if we really need a DSL to kind of do this. And that was something that Guido was thinking about a little bit, but not really, it was like whatever for him. But like Nick Hoffman, for instance, is interested in these kinds of things, AST rewrite. So of those three things, though, what's interesting is, two of them have materialized, right? So we made Anaconda and Conda, so now the packaging problem is basically, well, maybe it's too bold to say it's basically solved, but I think we have a good lead on solving the packaging problem. And then the matrix multiply operator got accepted, which is fantastic. I think what it shows is, there's another talk I give where I sort of talk about the history of how great how Python and numerical Python have co-evolved. So basically, some of the things around slicing and lists, building in complex numbers. There's no complex numbers in Python 1.0, but they're there now. And having complex numbers and having actually a complex number type means that everyone who builds libraries and C extension modules around your language can agree on how they're going to represent complex numbers, which is actually really, really huge. And there's precision issues if you represent polar versus representing, with I and real. But the idea here is that the Python language, in general, has been very, very receptive to the needs of the numerical community. So, for me, it's like the impact is it reaffirms, I guess, to a lot of the scientific community that Python is as receptive as it's ever been, and I'm interested actually to see. Like me, I'm always interested to see the abuses of it. Right? I'm going to see like how people overload one more thing to override, and under. But overall, no. I think it's just reaffirming and revalidate, sort of continual validation that Python is a great language for numerics.
So I like your thoughts on tracking the community and the ecosystem over time. To a large extent, the scientific Python ecosystem was sort of bootstrapped by sort of the C and Fortran communities and code bases. I'm sort of curious what you think is going to happen 10, 20 years from now, both the scientific Python and the PyData community and the code base. What's going to happen in 20 years?
Yeah, so that's actually very, very simple, right? Because I'm going to be wrong no matter what I say, so let's just go into it, right? So there's no... if it was like 3 years from now, I'm going to be called on it, right? But if it's like 20 years, no one's going to remember. But actually, I do talk about this. The reason for my Python meets the enterprise talk was, it was actually very simple. I was sitting there. Can you guys see that? You cannot see that. Oh, and what you do see is my notes, which are really embarrassing. Let's get that backdrop going on. There we go. Beautiful. There you go. Nice logo. The origin, I see my presenter notes too. That's not so good. View, show presenter notes. Anyway, okay. Well, so what I was talking about, the reason for that was because I was there, literally in the shower that morning of SciPy. I wrote that lightning talk that day when I was sitting in the conference. Some things never change. And so that, I was thinking like, well, am I going to be coding Python in 10 years? Am I going to teach my kid? I just had a kid in about 2 months before that conference, and I was like, am I going to be teaching him Python? Or is it going to be Squeak or JavaScript or something, right? And so I reflected on that. And I think actually the reason why I talk about this idea of the writing higher level languages, so I think in this slide, we have better performance, like better living through chemistry, right? Better performance through higher level stuff. And the reason I think writing this higher level code is actually going to keep it it's going to stick around longer. It's because the lower level stuff is what churns the fastest. The higher level stuff, the low level stuff, like it takes a lot of engineering effort to tape something out. It takes a lot of engineering effort to build an operating system and to build a language and a compiler and a set of standard libraries. All those things take, we have increased lots of effort, but they're still fundamentally capturing the expertise of people at those levels. It's very sort of stratified. But at the high end, you have like business expertise. Like there's people still running COBOL, right? Like there's the stuff that's still running on like the IBM like Z-series mainframes. Those things don't change because those business needs actually, the downside risk of changing those out is so high. So as Python is being used actually for more and more production stuff, that's something actually as a community I think is a hurdle, or not a hurdle, but is a thing we're gonna have to figure out. Because we love the dynamic, agile, prototyping nature of this stuff. At the same time, once we start rolling things to production, we have to like grow up a little bit and think about what does that mean for this to run for 5 years. And we actually already see this. I see it all the time actually in discussions about Python 2 versus Python 3. And you have people coming in and say, wow, I don't see why people don't just upgrade their code. It's so easy. There's not much to do. It's like, well, if you're an investment bank with like 2,000 Python programmers and you have millions and millions and millions of dollars every day writing on this Python code working, if it works now, why would you touch it? Right? And what that means is you have places that are running 2.4, places that are running 2.6. As a business at Continuum, we're not the only business that does this, right? There are many other companies that support these things. Red Hat actually is a very large business that has to support old Python for a long time. So that's something we have to figure out as a community. I do think Anaconda and Conda and like these nice packaging and environment things are really going to help that a huge amount. But looking again, 20 years in the future, I think there's always going to be a need to express your desires through the computer. The computer might get smarter and smarter about interpreting them, but I think people are always going to want it. There's always going to be a need for that high-level expression meeting the business. Business is always going to make first contact with computing infrastructure somewhere. And at that junction is going to be language. And whether that language is Python, a variant of Python, whether it's a weird Julia R Python with a little bit of Clojure script mixed in, whatever it is, those things always have to be in contact. And the reason why there always has to be a language-based approach, I was talking to Hadley Wickham actually at Strata about this. It was a great conversation. And we both, he's kind of in the R world, our studio, we're in the Python world, but we both fundamentally believe in the continuing demand for language-based approaches. Because if you have the kinds of things you can express through a GUI, the kinds of things that you can bottle up and capture in a graphical interaction are going to be moving at a slower rate. They're going to be better understood. They're not those exploratory things. They're not cutting edge, wiring in the most cutting edge infrastructure, computational infrastructure, hardware, what have you. The more things we have, the more heterogeneous our computing infrastructure, the more need we have for languages. So I actually see more fragmentation. What we actually have right now, I think we're coming to the end of sort of a period of monoculture, about a 20-year period of monoculture between Windows and Linux, and then x86. And so there's a lot more hardware coming online. Vector processing is all the rage again. All these things that were challenges in the 70s and 80s are all of a sudden relevant today. And so that period, like in the There's a great term, if I take just a second of time, there's a picture I show. If people are interested in this, you know what, screw it, I'm going to move this to the other screen so I can actually see it. There's a picture about this idea of Dennard scaling, which is that you don't have, the reason we have, oh, this will be embarrassing, okay. The reason that we have the fast microprocessor through the 90s is not because of Moore's law, but actually because of the fact that we were able to crank down the voltages on transistors throughout that time. So we're able to cram more transistors into a chip, but at the same time, we're able to turn them all on. And therefore, the chips got more powerful, and so software could just kind of keep doing what it was already doing. That Dennard scaling is now ended, and that's why we don't have 10 gigahertz processors now, is because at those speeds, at whatever the minimum VDD is, you're going to burn out your chip. Like the heat density is greater than like the surface temperature of the sun. And so you can't turn all of the silicon on at once. So even at a chip level, you're configuring blocks of compute. You're going to be writing software that turns on this thing, turns off the codec, turns this thing on, turns it off, turns on this massive, turns on the Bitcoin miner bit, and turns that off. That configuration as programming is not just, again, not hand waving, it's your reality, right? Like your phone, if it was turning on all of the silicon at once, it would last like 10 minutes, right? Your phone has a video codec, has a GPU, it's got all these things on it. All those things have to be configured in software. And that's going to be the reality of computing for the foreseeable future, I think.
So let's thank Peter for a very, very interesting talk and a lot of good insight. So thank you very much.
Thank you.
So we got lightning talks coming up in this room, so we're just going to set up for that.